Okay, what we're going to do today is tie a couple of things together. It's always nice when you study something that you can go back to something you studied before and tie the two together, and this works very, very nicely. Our concepts we were studying was photosynthesis and respiration, and we can take those concepts and tie them in very nicely with some ecology concepts. So that's what we're going to do today. We're going to put ecology and respiration and photosynthesis together. So in order to do that, you're going to need a couple of handouts. Just watch the extras at the end of the row.
I don't know, maybe bend your arm better, Brian.
Wish I could. Wish I could.
Why are there so many?
All right, two handouts.
No, we have
Any of these left over?
I have two pieces extra.
Okay.
They all the same.
You have two different handouts, yeah. Just two. Okay, good. So, the main topic for today then is going to be lake. Lake eutrophication. Connor, can you see if that shows up on the camera? I don't know if you can see from there or not. If you see any words at all, I may have written.
Yeah,
it
I
too
see
high.
some words.
Okay, they'll show up on a computer screen.
All right.
Okay. Lake eutrophication. So the question then is, what in the world is lake eutrophication? Well, if you go to any lake, I suppose in the world, but we're going to focus just around here. If you go to any lake in Michigan, or let's say the United States, you can classify that lake. You can say at one end of the scale, that lake is eutrophic, or at the other end of the scale, I'm going to make a smaller scale because I want to show you a picture. You could say that lake is oligotrophic. And so those are lakes at two opposite ends of the scale. And you have a handout of that. And so you see, I think on the top you have what do you have? An oligotrophic lake on the top, and you have a eutrophic lake on the bottom. And then you see that there's also a lake that can kind of fall halfway in between, and that would be called a mesotrophic lake. So you have eutrophic at one end, oligotrophic at the other end, and in the middle you have mesotrophic. The trophic status of a lake is pretty important. It's important to wildlife biologists. It's important to people who have cottages around the lake. It's important to fishermen. It's important to basically everybody. And that's kind of ironic because I bet you nobody here has ever actually even heard of those words. So let's take a look at what are these kinds of lakes. All right, over here then, let's start with eutrophic. And everything I'm going to tell you is sort of written on here on this handout. I'm going to expand on it just a little bit, so if you want to take some notes on it. So let's start with a eutrophic lake. A eutrophic lake tends to be shallow. And you see on this picture here, it's a shallower lake than the oligotrophic lake. And it's shallower because, well, either it simply was made that way, And we're not talking about God making them in the 6 days of creation. I don't think any of the lakes we see were made directly by God during creation week, because first of all, the flood changed everything. And certainly through the thousands of years since then, all kinds of things have been going on the surface of the earth. So various forces have created the lake basin itself. And so some of the lakes simply were created shallow, but some of them are shallow because they're filling in with sediments. And so that's kind of characteristic of a eutrophic lake. It'll be shallow, and it'll have lots of sediment on the bottom, probably a pretty deep layer of sediment. And let's just compare the two. Oligotrophic lakes, on the other hand, tend to be deep, and they tend to have a rock bottom, or gravel or something like that, but not very much in the line of sediments, at least if there are some sediments. And there's always some sediments in a lake, but it'll tend to be a fairly thin layer. And then I'm going to kind of skip mesotrophic, because mesotrophic is always going to be, well, it's kind of in the middle of the two extremes. All right, so that's one thing, depth. The second thing is that oligotrophic lakes tend to be colder, and eutrophic lakes tend to be warmer. So, and that makes sense because, of course, deeper lakes tend to have cooler temperatures. All right, the next item is plant growth. Eutrophic lakes tend to have lots and lots of producers. That is, green plants. Or they don't have to be plants, they can be algae. See this? Now there's some green plants in here, but can you see the green scum on the bottom of this beaker? Okay, that's algae. So they tend to have lots of phytoplankton, that's microscopic plankton, lots and lots of phytoplankton, as well as what we call macrophytes. That is, macro means large, phyte means plants, large plants that you can see, pick up, eat if they're good to eat, whatever. Caleb.
Can this occur in like any lake, like Lake Superior, Lake Michigan, or does it have to be a smaller lake?
No, any lake, including Superior and Michigan. Yep. Okay, so oligotrophic lakes then tend to have lots of producers, lots of plant life. Oligotrophic lakes tend to have little plant life or producers. Well, you know that if you have lots of producers, you're probably going to also have lots of consumers. Right. And so once again, eutrophic lakes tend to have lots of consumers. And oligotrophic lakes tend to have fewer consumers. And so let's name some consumers. What kind of consumers would you expect to find in eutrophic lakes? Seaweed isn't a consumer, that's a producer. Fish, all right? Fish, lots of fish probably. Caleb?
Bacteria.
Lots of bacteria, good. Ducks, correct. What else? You got ducks, fish, bacteria. We're missing a lot of middle ground there someplace. Turtles, did you say turtles? Good, turtles.
Clams.
Clams. What?
Frogs.
Frogs, yeah, frogs. Good. Crayfish, good. And then we're still missing something in between bacteria and crayfish and frogs. What's that? Yeah, insects. Good. Lots of insect larvae. As well as, we're still missing one gap in there, very important one, zooplankton. Right? Remember zooplankton, the microscopic animal-like plankton.
Like zooplankton?
Zooplankton. Zoo or zoo, either way. All right? Zooplankton. All right, so we have lots of those. Oligotrophic lakes, on the other hand, tend to have few of those. All right. Eutrophic lakes tend to run out of dissolved oxygen in the summer. They have lower levels of dissolved oxygen all the time. And as a result, they tend to run out of it in the summertime. Oh, actually, in the wintertime too. Anyway, so eutrophic lakes tend to have lower dissolved oxygen levels. Oligotrophic lakes tend to have higher dissolved oxygen levels. And why is that important? Why is it important to have lots of dissolved oxygen in a lake?
So the animals can live.
Ducks?
Yeah. No, like the fish.
Good. The fish, the zooplankton, clams,
Seaweed.
crayfish.
Algae.
Seaweed produces oxygen, remember? Photosynthesis. It produces its own oxygen. Okay, so good. All right. The question is, though, why is there a lack of oxygen? So that's going to take just a little bit of explanation. So let's take a little side trip here.